Good afternoon, everyone. Thanks for today's event. We will resume in 2 minutes. Thank you for joining. Hello, good afternoon, everyone. I am Alan, the host for today's event, and today's event is titled SQL Mysteries. And hold on. Yeah, sorry. And we have a genius with us here. Is I'm going to introduce him very soon. But before that, we can every participant should try to share the link that you used to join the meeting. Share with your friends, your colleagues, on your group, on your status, so that more people can join in and we can demystify SQL together. The link is in the chat box. Idris Haveda, and he is a highly motivated and results-driven software engineer with experience in full-stack web dev. He is currently a software engineer at Andela Big. Zubair is skilled in a variety of programming languages and frameworks, including PHP, Laravel, MySQL, JavaScript, Node.js, and TypeScript. Zubair is committed to delivering high-quality, scalable solutions that meet the needs of users. He has a strong track record of collaborating with cross-functional teams to deliver successful software products. In his free time, Zubair enjoys playing soccer and exploring new technologies. Ladies and gentlemen, I present to you the man of the hour, Zubair. Zubair, can you unmute your mic and say hi to the audience?
Hello, everyone.
Hello, Chief.
Okay, so good afternoon, people. My name is Zubair, as you rightly said, and I'll be working with us on this part of SQL. And yeah, let's see how much we can do in an hour. So, without further ado, I would go to share my screen. Yeah, hold on a second. Screen share. Okay. Does anybody see my screen now?
I can't see it yet.
Okay, hold on. Oh, so give me a sec. Let me try to join again.
Hello, are you there? Okay, I think he just left the meeting. If anyone can hear me, kindly signify. You can mute your mic and just let me know.
I can hear you.
Oh, okay. All right. So, yeah, Dio said he left so that he can share his screen properly. So let's give him a sec to get back. But yeah, before he gets back, I don't know, was anyone here on our space yesterday? We had the Twitter space yesterday. We discussed about love and tech. We have Twitter spaces every Friday, and we discuss about various topics. We discussed about combining tech and school. We discussed about joining communities, how helpful it is. We've discussed about the future of tech in Kwara State as a whole, and um, they have actually been quite impactful. We invite speakers from around the world. I think the first one of the was it the second one that we had. We invited someone from the US that came to speak to us. The next one we had after that um was taken by a Scottish lady. Yeah, so we invite people with vast knowledge to come and share their views with us. You can follow us on our social media handles. They will be dropped in the comment section, so you can be up to date with this information. Okay, Zubair is back. Welcome, Zubair. Sorry, apologies, guys. Zubair hasn't been able to share a screen, so we're trying to sort the problem out. We'll keep you posted as we go on.
Okay. Do you see my screen now? Can anyone hear me?
Yes, 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 we can.
Okay. Okay, sorry about that. So,
Yeah, we
uh,
are seeing. I can see that you are sharing your screen, but there's nothing sharing yet.
yes. Nothing yet. So, over
We
the
can see
course
that you're
of
presenting, but your screen, you can't
yeah,
see your screen yet.
yes, I know. I've not started anything
Oh,
yet.
okay, yeah, I can see it now.
Yeah, sir.
All right,
Over the
we can
course of
see.
the next hour, we would try to look at some very basic SQL features and then see how they are used and how they can help us improve our day-to-day use of the SQL language. So, without wasting more time, the first concept we'll be looking at today is an SQL join. So it's probably one of the most popular topics in SQL. Yeah, left join, right join, in out join. But what is actually a join? So in the most basic terms, a join lets you fetch data that is scattered across tables. So in SQL, you can have. Okay, let me go back to the content. So you can have many tables in a database. That's like the whole basis of SQL. You have structured data. Now, in a lot of cases, you find that you have only focused data in a table. So, for example, this is an employee's table. You have the employee name, you have the employee salary, you have the department ID, and then the manager ID. But then in some cases, you want to display results that are something like employee name, salary, department name, and maybe even manager name. But then in this employees table, you only have access to the employee ID, salary, and then just the two reference fields. So how do you combine this table together with, let's say, the department table that actually has the department name and also the employees table that actually has the manager ID? Because if you take a look at this, every manager is also an employee of the organization. So employee with ID of one is managed by it is managed by themselves because that's maybe the CEO of the company. And then employee with ID of two, this Areda. Okay, this is something is wrong here. Okay, I wrote a query at time. But you have the employee and then the department ID. So to display the employee name and department name, you use a join. And a join in SQL is very simple. It's as simple as performing a basic select. So to get started, you can do a select all from the employees table and running this, you get, hold on a second. Okay, yes, I have a better employees table here, sorry. Okay, so select all from employees, and then you have the employee's name, the job, the manager ID, the employee's hire date, salary, uh, a commission, and then department number. So to select, let's say, the department name, for example, given the department number, you want to select the department name. So you can take a look at the department and then you find that department has name and also has department number. So that department number happens to be the only field that these two tables share in common. So easy way to do this is select employees and then you join. Let's use a very simple join. So you join the department table, and then when you perform a join, you have to specify a column that you are joining on because this table has many columns, the employees table, and also department table also has many columns. So you might be looking for employees that match a specific condition. So use the join to specify the table name and then use the on to specify the specific field that you want. So you can do a employee dot department number is equal to department dot what is the name of the field? Dot department number, yeah, sir. Department dot department number. So running this, you see that you have a longer table, whereas the normal employees table has only one, two, three, four, five, six, seven, eight, has 8 columns. But now your final result has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It has all the columns from the employees table joined with all the columns from the departments table, and they are correctly matched. So you have department 20, 30, match 30, 40, and it continues like that. Now, in most cases, you do not want a table that just has all the columns possible. So you want to select specific columns, which in our case would be employee number, employee name, employee job, basically all the fields in employee, but then department name instead of department number. So to do this, you can list out all the columns that you need from the employees table. So you have employee dot employee number, and then you have employee dot employee name, and also employee dot job, employee dot manager, employee dot hire date, and employee dot salary. Basically, list out all the fields that you have there, and then finally you can join department dot department name, and then your results looks like this. So you've been able to fetch data from a secondary table by basically joining that data to your main table, which is your employees table. That is as simple as a join can get. Now, this query could be written to be more readable instead of having to repeat employee multiple times, employee dot employee name, employee dot. You could use an alias. An alias is basically a nickname that you give to a table. So instead of referencing employee multiple times, you can just use E for employees, and then every time you have to use the keyword employee, you can just use E, and then for departments, you can just represent it with D, and then this can be written easier by using E for every instance of employee, and then your query becomes less bulky, and then D for department, and it also applies here too. And when you run this, you get exactly the same result. So that is the most basic type of join you have, and it is called an inner join. Now, one thing to note, however, is if you look at the bottom here, okay, I believe you can see my bottom, but if you look at the bottom, you see no errors, 17 rows affected, and you see some other details. But if you go back to your employees table and really, okay, you do actually have 17 rows. But if you check your department table, you have only 4 rows. So you have more data in your results than you have in your department table. And this is because in this query, your primary table is your employees table. So this is being joined to it, but this is the primary table. So the columns from the employees table are like the primary columns. You have to first get those ones, and then you check for situations when you have a department that actually matches the employee's department number, and then you join that to it. But these are like your main concern. So another thing to notice is in your department table, you have a department that has a department number of 40, the operations department. But if you look at your results here, there is no operations department. And this is very simple. It's just because if you look at your employees table, there is no single employee in that department. You only have 10, 20, 30 no employees in table 40. So there's really no need to display uh, a department that has no employee, if you are kind of like really concerned about the employees first. So that is it on an inner join. Now, you can implicitly specify that you actually want to do an inner join by typing out inner join fully, instead of typing out just join. But since just join is shorter, you tend to want to use that more often. So yeah, you still get the same exact result. Now, this query can be written even simpler without using without specifying the inner join at all. So I'm going to try to do that. Copy and paste it here. So you just remove the inner join or join completely, and you just use a comma. Now, when MySQL reads this, it reads it as we are trying to fetch data from this table and also trying to join this table to it. And if you specify a third table, it automatically knows that you're trying to join that table also to the first two tables that you have specified. So it's it can be that simple. So running this, okay, oh, okay. So instead of using on, use where. When you remove the join keyword, you cannot use on anymore because they are kind of like work together. They are complementary. So when you use from, you use where instead. So where employee dot department number equals department dot department number. Okay, my running correct query. Okay, yes, I was selecting something else. So yeah, running this gives you the same output as running the first one, the exact same output, just that this is shorter and you are not using the inner join keyword exactly. Now, the next type of join is the left join, and it's also very almost self-explanatory. But then the whole idea is you have two tables, and one is more important than the other. So the most important one is the left, the table on the left. It is given the higher priority. In this example now, the first table we wrote, because this is your right and this is your left. So the first table here, the employees table, is the left table. So in the left join, the left table is more important, and then you are basically just adding data to it. So every record on that left table would be displayed, and then uh, records on the right table will be joined to it. So a simple example would be select staff from departments, just to see what department looks like. And so left join employees table, employees table on uh, d dot depth number equals e dot depth number, and then you can uh, d dot dname and count star group by d dot dname. Operations as one. Okay, there's an error here. One sec. Okay, so if you do a left join, like the one in this case, you have your department table as the most important table, and it returns every row of this department table, and then it tries to look for data in the right table that matches the data in the left table. So To show you this, you see that operations table is now the operations department is now returned, even though it has no employees, and then all the values for the employee is null. But then because the left table is the most important table, it actually has to return every record there, and then you can see that okay, this one doesn't have any department. Unlike in the first query that we ran where it wasn't returned at all. So using a left join, the table on the left, whether it has matching data in the right table or not, every row in it would be returned, and then the ones that have matching data would have the data appended to them, and if they do not, it would return null as we see here. So it's uh, very basic, and then you have the right join. The right join is the exact opposite of the left join. It's basically select staff from employees, or let's say same examples. Let me just grab this. I pasted here. I grabbed the wrong thing. Grab this and paste. So if I switch to right join, you go back to having the same data as the ones you got when you did the inner join, because now you are focused on the right table, which is the employees table, and you want to return every row in that table. And when you find a department that matches that row, you want to return that department. So in this case, every employee actually belongs to a department, so you're having no null values. But then there's a department that has no employees, and so it is not being displayed at all. So that's also like the whole gist of using a right join. And let's say one more type of join, a self join. So self join. Now, based on the name of this, it is self-explanatory. Self, it basically means you're trying to join one table to itself, and you might wonder why you would ever want to join a table to itself. But a very popular use case is in a table like this one that we have, where you have where everybody in the organization actually exists in the employees table. So you have uh, every employee has an employee number, and every employee also has a manager. So if you check, for example, this employees manager is 7566, and if you check here, you should find 7566. So every employee is either somebody's manager or somebody's subordinate. As long as you're an employee of the company, you are registered in the employees table. Now you might be somebody's manager or not, but you are first an employee of the company. So if I wanted to do something like uh, a query like select employee name and also something like manager name from employees table. To do this, I would have to use a join. So I have to use a self join because the data that I'm looking for, the two sides of data that I'm looking for exist in the same table. So to do this, I would do from employee, and then I would join the same employee table again. So to differentiate between the two tables, that's where the alias that I explained up here comes in. So this can be, uh, let's say A, and this can be B. Now, A is supposed to be for the employee, and B is supposed to be for the manager. So you can do on A dot manager equals B dot employee number. And then from here, you want to display A dot E name and also B dot employee name. And then you can just alias this as manager. So doing this, you find that Ford is managed by Jones, and Scott is also managed by Jones. And if you go back to your employee table and you check manager, see that Ford is managed by a user with 7566, and 7566 is Jones. So you find that his job description is actually a manager, and then Jones is one managing Ford and also managing Scott. So our query gave the correct response. So yeah, you've been able to fetch data, two sides of data from the same table. So you're fetching an employee and also the employee's manager from a single employee's table. So that is it for SQL joins. If you have any question, I'm going to take a minute break now so you can ask your questions on SQL joins before I move on to the next thing.
Hello guys, if you have any questions, you can ask them now or you can drop them in the comment section. Um, Zubair, you can continue for now.
Yeah, okay. So I'm just going to try to drop a link to an article in the chat section. So this is an article that explains joins more, so you
Alright.
can decide to further your knowledge on that. So the next item is SQL triggers. So if you're familiar with JavaScript, getting this, understanding this concept shouldn't be too hard because a trigger is basically like a JavaScript event listener. So you set up a trigger to listen for specific actions on your database table. So, say for example, you want to do something every time a new record is inserted, or every time some record is updated, or every time a record is deleted. You want to run some code, you want to do some validation, you want to do some additional processing. You can set up a trigger to listen for these actions, and then when the action happens, the trigger jumps to life. So before this call, I created a users table, so you can see it here. It has two users where one has some sort of encrypted password, the other does not have encrypted password. So I'm going to basically just try to insert into users table, copy as insert statement, paste, and I'll just edit some details here. Test, sample man, and Zoops are test, and username would be Zubi4234, and then password is just password. And when I run this, I get no errors, one were affected. I go back to my content and refresh, and I see the new sample man that I just created. Now notice the password is just a plain password. Now say I want to automate the process of kind of like hashing the password and maybe capitalizing this. I can create an SQL trigger, and it's very easy to create. All you have to do is just use the create trigger keyword, and then a trigger has a name because when you create the trigger, you can create the trigger and it will continue to run for life. So you can always use the name to reference it in future if you forever for any reasons have to delete it or something like that. So you can have a trigger called impute format or something. Just any random name would do. And then the trigger, next thing the trigger takes is, or let me just give you a sample structure of a trigger and then I'll explain line by line. So this is the general shape of the trigger. It takes in the create trigger keyword and then it takes in a name. Here I'm setting the name to be impute formatter, and then it takes in a trigger time. Now, the trigger time is basically when you want the trigger to be fired. So it has only two options. It's either before the action. So let's say before I insert a new user, I want to do something. Or let's say after this user has been inserted, I want to do something. So you can decide to use either before or after. But in this case, the first trigger I want to create would be want to uh, kind of like hash this password. So it's going to be before it is created, immediately it gets in, I want to hash it and then I want to store it. So I don't want to do it after it has already entered database. I want to do it before it enters database. And then the trigger event is what event are you listening for? So it could be insert, it could be update. I want to perform an action every time before a data gets updated, then it could be a delete. So before you delete this data, I want to do something with it one more time, or I want to delete it from this table and store it in this table. But then, so yeah, I want to do before insert, and then a trigger works on a specific table. So kind of like listens for the insert or whatever action you set on that particular table. So I can say on my users table, and then it takes in this compulsory keyword for each row. And what this basically tells you is a trigger runs for every single row. So if you have, let's say, I have multiple inserts now. So instead of this, I decide to grab this and paste. If I have like 50 rows, I'm trying to insert all of them at once. The trigger doesn't just run once, it runs 50 times, checking every single set of values that is coming in and performing whatever logic I ask it to perform on every individual set of values, and then it lets the insertion happen. So, and then the trigger body now is what code do I actually want to run before this insertion. So yeah, it's going to be something simple as just saying new. And yeah, new is also a MySQL keyword that is used when you're using a trigger. So when you're working with triggers, you have access to two new keywords. You have the new and you have the old. Now the new is used for accessing data that is coming in, and this only works with insert or update event, because it's only when you're inserting data or when you're updating data that you actually have new data being created. Because when you are trying to delete something now, there is no new data, you're just removing the former data. So when you're using the new, it works with insert or update. But when you use the old keyword, it only works with update or delete. When you are creating a new data, there is no old record of it in existence. So you do not have access to the old keyword when you're using the update or delete keyword. So yeah, I'm performing an insert. So I have access to new, and the new is an object, so I can access new dot password, and that's basically mapped to whatever password I set here. So it would be at the last item here, which is password. So new dot password, and I can modify this as I want. And the only reason why I can do this modification is because I am performing this before insertion. If I were to do after insertion and I use an equal to here, I'll get an error, because by the time I get to this level, this has already been inserted and it's already in the database. So anything I'm doing at this point is actually not part of the original insertion again. It's already becoming an update. So when you use the before uh, trigger time, you have access to the data and you can modify it because it is yet to be stored in your database. So new the password is I can use a couple of inbuilt SQL functions. So you can basically you can just use the MD5, and note that this you might not use this in real applications. This is only to explain how a trigger works to you. In real applications, you'd very likely encrypt your password from your application level. So to new dot password. So what this does basically is it listens for insert events. Every time I try to insert some data in the users table, just before this insertion happens, I want to encrypt the password. So I run this. Uh, okay, I didn't. How does this keep happening? Uh, for each row. Oh, sorry. Set. Oh yes, I forgot the set keyword. So now, after running the trigger, you see no errors, zero rows affected because now you're not actually touching the table yet. So you're basically just attaching something to the table. So I'm going to try something. I'm going to say this is password one, this is password two, this is not a sample man, and this is OGYR. Yeah, same email, and this is I sample me, and this is not an OG. So if I run this insertion again, I run it, you see no errors, two rows affected, and I come to my database and I refresh. Now you see that the password I passed into this insert was password one. But in my database, I'm getting a different value. That means every time I run, and then the other table also the not an OG, you find that you also have its own kind of like hashed password. Now, this means that this actually works as expected. So every time, just before you insert uh, new data, the trigger is fired, and then the code here is run, and yeah, it works just as expected. Now, the trigger works for more, can be used for more complex uh, stuff than just kind of like encrypting password. So, some of the most popular uses of a trigger has to be like maybe the first one is login. What you usually do is, let's say insert after insert on users table for each row, instead of set, I want to perform a whole database operation, insert into, let's say, logs table, sample logs. So insert into sample logs, and then I just have maybe my set of values, and I can do something like I have the ID, I have new user created or something, and then I can access the user ID using new dot ID or something like this. So if I add this sample table, every time a user is created, I'll automatically see logs in my sample logs table that says that's an ID, a new user created message, and also the ID of the newly created user. So this is API is very useful for setting up automatic login. So every time data enters your table, maybe even after update, you also want to log something. After delete, you want to log something. So it is very easy, and you don't have to bother about logging again. And a second popular use case of a trigger is validation. So for each row, I'm going to create another trigger because the first one is still there. So let's say password. No, let me not do password. Let's say username checker. So before, so for this I'll do before update. So just to show a different one, before update on users for each row. Uh, if okay, so let's say I want to check if hold on, let me see something. Hmm. Okay, so let's say I have a separate table, maybe sales table, and then on that sales table I have an amount. So if new dot amount greater than, let's say, 200, I want to work with that new dot amount, and if not, I just want to set the base to 400. So you can use a simple trigger like this, and every time data comes in, if data is greater than 400, data comes in, and if not, it just automatically assumes this basic. So you can use a trigger for data validation and maintaining data integrity by just letting it check the data, and then if some certain condition is met, you want to uh, perform some uh, action, and if not, you want to maybe set up a new value. And the final, maybe one of the also very important uses of a trigger would be for data synchronization. Now, data synchronization in the sense that, say you have a sales table, and then you have another customers table. So every time somebody makes a sale, you want to update customers where new before insert. Sorry, let me say after insert. So after you make a sale and the new sales record is created, you want to update customers where the new uh, on your sales record you have the customer ID, where customer ID equals, sorry, where ID equals new dot customers ID, and you want to set the customer's balance, and you want to just add the new dot total or something like that. So this way you're able to maintain your data synchronization. Your data remains updated. So every time somebody makes a sale, you don't have to bother about updating the customer's balance, because now you have a trigger that after every sale record has been created, it looks for that customer where the customer ID is the ID you passed in, and then just sets the balance of that customer equals the former balance plus the new dot total. So yeah, that's it for triggers, and I'll take another minute break to take questions if you have any.
All right, Chief. Thank you. Nice one. Well done. I have a question from my own end here. Yeah. So,
Yeah, I can.
are triggers like conditional statements? Like, for instance, the if, when, sorry, the if else statements.
Oh no, those are separate, but you can use that in a trigger. Okay. Those are. Let me look for something to share. Okay, see this salary field now. Those are very different fields. So you can do something like, okay, let's just do select stuff from employees. Now you see like these employees have salaries, right? So if you want to use an if statement, I just want to show you how an if statement is not exactly related to a trigger, but then you have the idea of if statement and stuff, logical conditions in SQL. So you can just do when salary greater than, let's say, 10,000, then I want to say each man when, let's say, salary greater than 5,000. Okay, I should be able to do between, when salary between 5,000, 10,000, then you can say not a broke man, and then else you just want to say broke man, and then you want to do end, and you can say maybe status broke work state. Okay, yeah, you got an error. When shall I, okay, when shall I greater than 10,000? Okay, case, what's this? Case when shall I greater than 10,000? Then, when shall I greater than 5,000? Then, okay, let me check something. When salary greater than 5,000 and salary less than 10,000. Okay, now you see, I just used a simple if statement in SQL, even though I didn't have to use if, but then you get the whole idea. So in the trigger, you can also use a conditional, but then it is not like attached to a trigger, but it's just you can basically write any valid SQL query inside of a trigger, like this one now updater. But this is how you use a conditional in SQL. So you have case when, let me just try to format this to be a bit more readable. One sec. No, no, wrong. I just copied the wrong thing again. Oh, okay. Format document. Okay, yeah. So this looks better now. So this is how you do a conditional statement in SQL. So you use the case keyword and then you end it with end, and then for each if else, you can just do when something, then something, when a condition, then. So for this, it's when greater than 1 5 and so yeah. Any more questions?
Oh, okay. So, the trigger is more like a function.
If you Yeah, it's more like a function. If you write JavaScript or yeah, any language basically, most languages have an idea of events and event listeners. So you know in JavaScript you can have an on-click event, and it's when you write the on-click event and you give it the function, nothing actually happens. But after every time somebody clicks, the code in that on-click event is run. So for this one now, this update customers UID might never get run in future. It might just be there, might just die there. But if someday in the future somebody comes and insert a new date, a new record inside of this sales table, then this would automatically fire. So it's basically a function that is waiting to be run, but it is waiting for a condition, an event to happen before it can be run.
Okay, I get now. Thanks, Chief. You can move on. If you have any questions, please signify. You can unmute your mic and ask. Or if the question comes as it continues, you can just type it in the chat box.
So the next one is a common table expression, and even though it has common in the name, it's not that common. But so a common table expression is basically like a subquery, but then it's supposed to help you write cleaner code and also more performant code. So I would clear all of this and say I need to find the employee that has the highest salary in this table. So once again, I start with my usual select star from employee. Now, first I need to get the highest salary, and then next would be to find the employee that has a salary matching that value. So I can do something like select max salary. Now I have a query that gives me the highest salary, but then there is it's not exactly easy for me to get this value and also just easily find the employee that has this salary. So what I would do is I'll write another query. So I'll do select star from employees, and then I'll pass in where the employee salary is equals to. I'll now come here and basically paste this whole query inside of here, and I'll run it. and now I find only employees with the highest salary of 12,000. Now this doesn't really look like a problem because it is a very very small uh, query. But then let's say I have to find employee with highest salary, employee with smallest salary, and stuff like that. I find myself having a lot of sub queries, and then my query starts getting long, and then I start having many brackets and stuff inside of it. So it becomes messy. So an easy way to solve the problem is to use a common table expression. So a common table expression is very easy to write. You start it off using the with keyword. So when you use the with keyword, you give it a name. So you give it a name like, let's say, highest employee salary, and then it now takes in some code. So this is the name of the common table expression, but then we've not written any code, so it doesn't automatically just know the highest employee salary. So it takes in the code here, and the code is just this code I've written earlier to select max salary from this. And note, unlike every other SQL statement that we've written so far, it doesn't end with a semicolon, but it is immediately followed with uh, a query that uses its value. So you can do select staff uh, from employees where salary equals select. Okay, let me do value. Okay, no, value doesn't work. I. Okay, so equals select I from highest employee salary. Yeah, and I hope this works actually. It's looking like this. Yeah, I know it. Uh, okay, it works now. Now, what I have done here is, no, it looks like it's more code than the first one that I have. What I've done here is, if this subquery ever needs to expand in future and stuff, I know that all the logic for that subquery will always be inside of this highest employee salary common table expression that I have created. So my code becomes cleaner to read. And then I can also have another common table expression, let's say lowest employee salary, and that also lives in its own kind of like cage, minimum of minimum salary from employees, and everything still works fine. So you can have many common table expressions where each common table expression has its own name, and then it has some code that it runs, and then it is kind of like structured, and your code is easier to manage. You can basically change something inside of here without having to repeat it in multiple places. And then instead of using this query here, you don't have to repeat the query multiple times because it is in one place, and then can just access that one place here as many times as possible. So that's the idea of a very basic common table expression. It saves you from writing subqueries multiple times, and it also brings in readability by helping you organize your subqueries and giving them a name and stuff that can be referenced later on. Now, there is a very popular type of common table expression, and it's called the recursive common table expression. And if you're familiar with programming before, you know recursion basically means doing something, recursive common table expression, doing something over and over again, over a couple of times. So that's basically what a recursive common table expression does. It brings the ability to loop over data. It brings it into SQL. So it means you can do simple, not simple. You can do complex stuff like, let's say the most basic one. You can display a set of numbers. Let's say 1 to 100, using a very simple sheet commentable expression. So you have with recursive. Now, once you pass in the recursive keyword, that SQL knows, okay, you're about to loop, and then it keeps track of it. So with recursive, one, okay, 1 to 100, 1 to 100, as yeah, your query goes in here. Now, unlike the initial query that we wrote, where you can just have like one line of what you call it, one line of a query. In this case, you have the subquery. Okay, I forgot. I mistakenly put this here. The subquery you're going to write will have two parts. It should have a base part. It should have a union, basically to join the two parts, and then it should have a recursive part. Now, if if you've written any JavaScript before, this is basically saying something like uh okay, for let I equals 5, I plus plus, and I less than 10. So this is basically MySQL's version of this, where the let I equals 5 is the base part. This is where you're starting from. This is your initial query, and then you have the union basically that says, okay, select this data, join whatever you get here to it, and then go again when you have more data, join it again. So, and then the recursive part is basically like the looping part. So this part of it. So, uh, coming back to the city to display numbers, so you can start with select one. Now, you're selecting one because it's what you're trying to work with is static. You want to display 1 to 100. You're not exactly fetching from a database. You're trying to loop, but you're starting from one. So this is the same as saying let I equals one, and then you have your union. Now you can use either union or union all, union or union all. In in SQL, you use union all when you want to, when you have a couple of, okay, let me just show the example. Okay, so example of difference between union and union all. Okay, so I'm just going to grab this. Oh no, oh, these guys have the same ID. There's no differentiating factor. uh, uh okay, I'll just select one of them. So grab this. So I'm selecting all from this city that I created. Oh, I forgot to end this. So I'm just going to comment this out for a few, and then run this. I get three values, and then I do union all, and I just basically grab this same query that I'm running. And when I run it, I get 6 rows. That's because when you use union all, it takes results from the first query, the query before the union, this one, and then joins it with the result of the query after the union. So you have since it's the same query, so you have the same three set of data joined with the same three set of data. But when you use union first joins them, and then it filters out the ones that are the same, and it keeps only one. So when I do this, I get only one row now, because when I use union, it selects only the unique ones. So joining this and this would actually give me 6 rows of exactly the same data. So that's basically the quick difference between union and union all. So if data you are looping over might be repetitive, and you still want the repetitive value, use union all. But data you are looping over my repetitive, I don't want you to use only union. So I'll use union for this part. And also a very tricky part of using union all in a recursive CTE is it's the same idea as in it's basically like a loop. Let's say you have one, two, three, four, five, and you have another five, and let's say you have another five. When the query runs, it takes five and then it sees another five, and then it still thinks it's on this five, and then it still thinks it's on this five because it's still seeing five and stuff. So it might just die on this single five and keep thinking it's running like it's progressing and stuff. So union, and then for the next part of the recursive city, I'm going to select. I'm trying to get this one value. So to get this one value, you can pass in a parameter to your city as I did here, where I basically give this an alias of I, and then I could use the I inside there to access this value. So I'm going to just pass in a simple alias here, let's say X, and then so I want to select X plus 1, and then if I stop here, I'm going to have an endless loop, an infinite loop, basically because I'm saying, okay, select one, which is same as let I be one, and then I'm doing select x plus one, which is basically same as I plus plus, and then I'm removing this check. So without this check, the code will just keep on running till infinity. So if you actually try, your MySQL would stop you. Oh, sorry, there's okay. Stop. I forgot to. So just select star from the city, and also I forgot the from. Now this is the key part of a recursive city. You can select data from itself. So the city that I'm just creating, I'm selecting data from it. That is how I'm able to access this first value of one. So recursive city, it selects one. I have one row, and then I can select this one as x from it, and then I get x plus one, and then it stores that, and then x plus one becomes x. And I'll just show you this. Okay, so if I run this, you see at the bottom here, I get a recursive query aborted after 1001 iterations. So it actually kept on running, but then my laptop had to stop it for due to management settings and stuff, which makes sense. So I can do where x less than, let's say, 500, and when I run this, I get 1 to 500 automatically. So let's actually go over what happened here quickly once again. So I start with select one. At this point, this basically gives the same result as running select one outside. So I select one, I have one. Now in the next part of it, I use a union, which basically is same as saying select one union, and I can do select one plus one. Now I get one, two. Now this after this first one, it actually gets inserted, and then X assumes the value of this one, which is my starting value. So at this point, select X plus one. It's same as doing select one plus one, and then it in SQL normally the way part of a query is run before all the other parts, and if you think about it, it actually makes sense because if you do something like select stuff from mad people list, mad people list. If you run this, it throws an error because the table doesn't exist, and it's able to throw the error very quickly because instead of trying to select or order by or do any other thing, it goes to the from section, from or where section of your table, and then it performs those ones first. So it first checks if the table exists, and then checks if x less than 500, and then it does the final parts of it. So after the second uh After the second line, at this point, x is now 2. It comes back here. It checks is x less than 500. So because 2 is less than 500, it checks. And then it comes back here and it does 2 plus 1. I know you're using union. So it's basically another union. Select 2 plus 1. And then you get 1, 2, 3. And then it continues till it gets to a point where is x less than 500. Yes, and then till a point where x is not less than 500 anymore. So if you check this again, you see you have 1 to 500. And the reason why you actually have 500 included is because the item just before 500 is 499. So when x is 499, you find that 499 is less than 500, and then it inserts 499 plus 1, which is 500. And then for the next one, x is 500, and then this doesn't give 2 again, and then that's the end of it. So does anybody have any questions? This would be the final section. I'm already out of time. So yeah, it's not advanced. Okay, it's somehow advanced. It's not like the everyday basics, but then it's not the most advanced thing you can do in SQL. So does anybody have any other questions? And we'll call it a day after this section. Okay, so no questions. Then uh that is it for me then. It has been nice being with you people. Yeah, somebody should do the way.
Sorry, Chief. I had to. I was off for a while. Um, well done, boss. So, are we still going to take the fourth topic for today? We have I think common basic expression was the third.
Yeah, but
Then we are
I
supposed to go
was
with.
trying to keep to the 1 hour time, and I set a
Oh,
timer
well,
before I
I think
started.
there are
So
actually 3 hour. It's actually a 3 hour thingy.
ah
I think. Let me
yeah, I do
confirm.
not yeah, I do not have that much content, but we could quickly go over
No,
window
no problem.
functions.
No problem. When you're done with the last one, we'll just close up there.
Yeah, okay. So
Yeah, Chief, well done.
uh to understand window functions, you have to know the basics of kind of like aggregate functions and kind of like grouping in SQL. So an aggregate function is a function that runs. Okay, let me just try to take out something. So if you do a select, or let's say, yeah, let me just try select. So if you do a select, what's this? So select star from employees table. It returns uh, all the rows in the table because it's kind of like checks each one by one, and then it returns them. But if I do prove that it checks each one is if I do a where depth no equals, let's say, 10. So it goes over every column in the table, and then it checks if department is 10, and then it returns the data. But then an aggregate function, on the other hand, works with groups of data. So if you do select sum of salary, you get back only one row because this aggregate function, sum is an aggregate function. It takes in all the rows in the table, takes them as one, does the sum and returns just one record because it sees them as a group, a collection. So some returns the aggregate functions only return uh, data based on a collection or a group of data. So you can have some and have max salary. So if you try to get something like, let's say, employee name, you get an error and it says in aggregated query without the group by expression 3 of select list contains non-aggregated column. And that's because now you are not dealing with individual rows anymore. You are dealing with those rows combined together to form a single group. So you're trying to fetch employee name. Which employee are you actually fetching? Because though all employees have been grouped together into one collection, and now you can only access data that exist on the collection, so like I can easily get the maximum, the minimum, and yeah, those are aggregate functions. Now, window functions, on the other hand, they are almost exactly like aggregate functions, except for they let you, so you can do select star from salary from employees again. So a window function lets you kind of like define the group more easily. So if you do some in an aggregate function where you do some salary, you cannot select the employee name, for example, because you have access to only the group. But then in a window function, you have some salary, and then you can specify your window. The over is basically the only syntactic difference between an aggregate function and a window function. So you can specify a window here, like you want it to be from a particular point to a particular point, and it also lets you return the data joined to every single item. So for every item here, a window function actually runs. So for this first item, it checks the sum of everything and attaches it. For the next item, it still tries to calculate the sum of everything. So if I do something like partition by, so let's say depth, no. Now you find that you have now you find that you have different sums for different values. For example, you have this one 48,000, and if you go down a bit, you have 10,000, and you go down a bit, you have 9,400. Now, this is because, as I have said before, for every item, a window function runs whatever you say. Yeah, so you are summing the salary, but now you're only summing salary for a given department. So that people that have the same salaries now, they are all in the same department. So even the same in department 10, they find that they have the same sum. People in department 20 have the same sum because for every item, it checks, okay, what is your department, and then what is the sum of salaries in your department. So if you're in department with multiple people, all of you get to have the same sum for this.